Okay, I'm going to quickly go through the steps of converting a decimal number into a floating point number. And then we're going to look at a floating point number and converting it back into a decimal number. And those are the only two things that you're going to be asked in the exam. Actually, no. And plus, you'll be asked what are the advantages and disadvantages of using floating point, and that's on the sheet that I've given you. And so don't worry about the negative numbers at all. And I'm going to go through two examples, and then hopefully you should be able to do this in your exam. So the first number I'm going to start off with is 2.75. So the first step that I have to do is I have to convert this into a binary form. So in binary 2.75, I've got my sign here. Because it's a positive number, it's going to start with a 0. I've got my 2, I've got a 1, and I don't have a 1, I've got a 2. I've got my point, I've got a half there, and a quarter. So we've got 1, 1, 1, so that equals 2.75. So in binary, 2.75 is 010.11. Now, in the exam, it will tell you if it's an 8-bit signed mantissa and a 4-bit signed exponent. It might be a different number in your exam. So the first thing that we're going to do is we're going to work out the mantissa points. So all that is basically doing is, first of all, because I know that it's 8 bits and it's signed, so first of all I've got my sign, and then I know that's my 0.0, and I've got my point there, and then I've got a half, a quarter, 8th, and so forth, 16th, 32, 64, and 1, 2, 8. So I've got 1, 2, 3, 4, 5, 6, 7, 8. So here's my 8-bit. And it starts with a 0 because it's a positive number. And I'm simply just transferring that number over. So I've got 1, 0, 1, 1. And then I'm going to pad this out with zeros because the examining board, imagine the examining board said it's an 8-bit mantissa, but obviously I've got 2.75, so I don't need those bits at the bottom. Now, the second part, or the third part, if you like, is how many decimal places did we move it to start with a 0.1? So we moved it back 2 decimal places to start with a 1. And so in exponent, we've got a 4-bit exponent. So the first bit is a sign. Then in binary, we've got 4, 2, and 1. So what we have here is that's going to be 0 because it's a positive number. 0, and we've moved it back 2 decimal places. So that's 1 and that's 0. So here's our 4-bit exponent. And this is our 8-bit mantissa. Okay, so let's see if it's actually the right answer. So what we're going to do, first of all, is we know that a half is 0.5. Then we don't have a quarter, we've got an 1/8, which is 0.125. And we've got a 16th, which is 0.0625. Okay, this is just to check it. And I believe in your mock exam, they just want you to come up with this number here when they've given you the number. But if you've got time to go back and check it, it's always useful to do that to make sure that you've got it right. And if I add all of those up together, that equals 0.6875. And then we're going to add it, we're going to multiply it, sorry. We're going to multiply it by 2 to the power of 2, which should give us 2.75. Okay, so the reason why we multiplied it by 2 to the power of 2 is because, remember, we moved the decimal places back 2 places, so the exponent was 2. So hence why we've multiplied it by 2 to the power of 2. Okay, so we're going to do another example, which is a bigger number, which will be similar to your exam paper. So let's think of 8.1375. I believe it's not this big in your exam, so I think I've just made this a bit more difficult for myself, but anyway. Right, so let's just do the binary. Got 1, 2, 8, got a 64, got 32, 16, 8, 4, 2, 1, got a half, got a quarter, got an 8, and I'll just add the 60 onto here. So, okay, we've got 164, we've got 16, got 1, that makes 81, and then a quarter plus an 8 makes 0.375. Okay, now in your exam, or maybe in your exam, it might say 12-bit mantissa and a 6-bit exponent. So let's do our mantissa bit first. So the mantissa bit again is just literally transferring this number over. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I hope. I've got my sign, I've got a half, a quarter, an eighth, 16th, 1 over 32, 1 over 64, 1 over 128, 1 over 2, 5, 6, 1 over 5, 1, 2, 1 over 1024, 1 over 204, 8. Okay, so first of all, we're going to simply transfer this number over. 0, 1, 0, 1, 0, 0, 0, 1, 0, 1, 1, 0. You can see where it's going to be difficult to work out whether or not this is going to be correct or not, but we're going to do that. So this is our 12-bit mantissa. Now the next stage is, now to get to this 0 point number, how many times have we moved this decimal place back? So let's move it back now. So we've moved it back once, twice, 3, 4, 5, 6, 7 times. So we've moved it back 7 times to get to this number over here. Now, so 7, and then we've got our 6-bit exponent. Right, so our 6-bit exponent, so we've got our sign, 16, 8, 4, 2, and 1. So we've got, so that's going to be 0, 0, 0. 4 plus 2 plus 1 is 7. So here's our 7. Now, here's our lovely numbers. So we've got a half, which is 0.5. That's our 0.5. Then we've got an eighth, which is 0.125. Then we've got our 1/28th, which is 0.0078125. And we've got our 512. I promise you, I'm pretty sure the number is a lot smaller than this. We've got 0.019533125. We've got our 1 over 1024, which is 0.0009765 which equals 0.6357421875. Okay, then we have to times it by 2 to the power of, and our exponent was 7, and it should bring us back to 81.375. Let's check the answer on the calculator. So we've got 0.5 plus 0.125, which was our eighth, and then we had our 128, which was 0.0078125, 125, and then we had our 1/512, which was 0.001953125, and then we had our 1/24, which was 0.00099765 765,625, which equals 0.63. That should be right. And remember, we moved it back 7 places, so we're going to do 2 to the power of 7, which should hopefully bring us 81.375. Okay, so the other question on your exam paper will be to convert a floating point number back to its original value. So we're going to work backwards now. So for example, if you had a number like 0.1010011. Now in the exam they've left the space, so we know that this is the exponent. So if we go back and we just do 2, 1, we know that this is going to be the sign. So we know that this is to the power of 3. So we straight away know that the exponent is 2 to the power of 3. Now let's work out what the actual number is. So I'm just going to make a new table here. So we've got 0.1010. So we've got the sign there. We've got a half, quarter, 1/8. and a 16th. Right, so what have we got? We've got 0.5 plus 0.125, which gives us 0.625, and then we're going to do 0.625 times 2 to the power of 3, which gives us the number 5. Okay, and we can check that on the calculator as well, just to make sure we've got it right. So what should we have? We had 0.5 plus 0.125, which gave us 0.625, and we timed it by 2 to the power of 3, which gave us 5. Okay, so I'm going to do one more example, and that should be all that you need for your exam. So I think it might be a slightly bigger number, so let's do a little bit of a bigger number. So let's say that this is not the actual number in your exam, but it'll be a slightly bigger. So we've got 0, 1, 0, 0. So we know that we've got 4, 2, 1, so we know that it's to the power of 4. And let's just move this number here. Let's get that. Got a half, a quarter, an 8. Okay, so we've got 0.5 plus 0.25 plus 0.125, which gives us 0.875. Now in this exam question, you'll be given 3 marks, so they want to see the 3 steps. So we've got 0.875 times 2 to the power of 4, because remember our mantissa was 4, which gives us 14. And I'll let you check that on your calculator to make sure that it's right. So those are the 3 things that you're going to be asked: the advantages and disadvantages, converting a decimal number into a floating point number, and then converting a floating point number back into its denary value.